Section 9.5, linear equations. So specifically this talks about linear differential equations. That's what it means, linear differential equations. And what we're going to learn here is how to solve linear differential equations. Last time we did separable differential equations, where we separate the x's, separate the y's, integrate both sides, and then solve it from there. Here we learn how to solve linear differential equations. What are linear differential equations? So we say first order linear differential equations are those in the form that are written in the form dy dx plus p of x times y equals q of x, where those p of x and q of x are continuous functions in x over a certain interval. So all the differential equations that they take this form, dy dx plus p of x y equals q of x, are called first order linear differential equations. And the question is how to solve them, how to solve such equations. Now one thing you are going to notice about this, no matter how you try to separate them, those are not separable. You can't separate the x's and y. So we need another tool to help us solve such equations. And what's the tool here, or what's the trick around this? How do we go about this? So to go around this or about this, we multiply both sides by another function. Another function, we call it I of x, so that when I multiply the left side, which is y prime plus p of x y, if I multiply that by I of x, I like the right hand side to be the product, the derivative of the product of I of x and y. And why is that? Because when I integrate both sides, the integral will drop the derivative. And we'll see that in a minute, what we mean by this. So now, watch what happened. I only multiplied the left-hand side. Like I wanted the left-hand side, when I multiplied, to look like the derivative of the product of I of x times y. Don't forget that also we have to multiply the right-hand side, so I of x times q of x, okay, of the given equation. From here we can do two things. Okay, we can get two things. The first thing is, on the right side, I can integrate both sides of the right stuff, like this right section. So the integral will drop the derivative. So you get I of x times y equals the integral of I of x, q of x, dx plus c, because you already integrated the left-hand side, right? So the left-hand side you could have put in like plus c, but you move it to the other side, minus c. Minus c plus c doesn't matter. We could divide both sides by I of x, because remember we're trying to solve for y. So it will look like this. The same thing, just divide both sides by I of x. And that will give me what y or y of x is. Y or y of x. The question is like, what is I of x? You're saying, oh, you multiply both sides by I of x. How do I get I of x? Right? How do we get I of x? So to see how to get I of x, we're going to look at the left-hand side, these two parts. Okay, what can I do on the left side? I can multiply, distribute I of x in. So I of x times y prime plus I of x times p of x times y equals, the middle term, I can do product rule on that. I can do I prime of x times y plus I of x times y prime. Notice how this and this cancel each other. That'll give me I of x times p of x times y equals I prime of x times y. And we could divide by y both sides. You get I of x, p of x equals I prime of x. So what I'm going to do is I'm going to find what I of x is. And to do that, we are going to rewrite I prime of x as di dx. Right? That's what it means. When you say y prime, dy dx. When you say I prime, di dx. And then from here, what we can do is we can use separable. We can use separable to this. Right? So we can put the p of x here, dx, and we have I or I of x di. Oh no, we need to bring it down, sorry. Di over I of x. I or I of x, doesn't matter. Then we can integrate both sides. Let me put the I on this side. Integral of p of x dx. So what's the integral of that one? This is natural log of absolute value of I equals, we don't know what that is. Remember, I want to solve for I. So what I can do is, I here, you can drop this e integral of that dx. I here, if I want to solve for I, is going to be plus or minus that, right? Plus or minus that. So you can do plus or minus e to that thing. Now, for simplicity, you can assume, take only the positive case for now to get I or I of x. So if I want to find what that function I is, or I of x, we do the integral. We do the integral, as you can see. So this formula will give me what I of x is, how to find I of x. And now we're going to see how to apply this to an actual example. Let's say we are asked to solve y prime minus y equals e to the x. You can tell here we cannot do separable here on this one. So what we have to do first is try to find what I of x is. That I of x is called the integrating factor. So notice, if you want to compare this to what we gave you, remember how we said it's y prime plus p of xy equals q of x. From here, I write what p of x is. It's negative 1. Q of x is e to the x. So I'm going to find I of x, which we proved it to be e, the integral of p of x dx, and e integral negative 1 dx. E integral of negative 1 is negative x. No need to put plus c or anything like that. Now, what do we do? We're going to multiply both sides by e to the negative x of that equation. So y prime minus y, e to the negative x, e to the x times e to the negative x. And remember what I want the left-hand side is going to always look like. It's the derivative of what? Of I of x. If I scroll back up, we want it in the middle here, I of x times y derivative. So it's going to always be I of x times y derivative. So I of x times y derivative. And on the right side, we get e to the 0. Again, I of x is e to the negative x times y derivative equals e to the 0 is 1. Keep in mind, we're trying to solve for y. What is y? Now, after we do this, we are going to integrate both sides. The integral of the left side is e negative x times y is the integral of 1 dx plus c. Don't forget the plus c. And what's the integral in this case on the right side? This stays the same. This is x plus c. And it's not done yet because I want to solve for y. So you can divide everything by e to the negative x. So when you divide that, you get y equals x over e negative x plus c over e negative x. It would be nice if you can rewrite this as x e to the x, c e to the x. Again, solve, let's say 4x cubed y plus x to the 4th y prime equals sine cubed x. So the first thing, I need to rearrange this. X to the 4th y prime, I put the y prime first, and then it doesn't look like y prime plus something. I see x to the 4th. So you could divide everything by x to the 4th. That will make it 4 over x after simplifying sine cube of x over x to the 4th. Now you can tell p of x is 4 over x, and q of x is the whole thing on the right side, which is sine cube x over x to the 4th. I need to find I of x. I of x by the formula e raised to p of x dx. And this is, if you pull the 4 out, and the integral of dx over x is natural log of x. And what you need to do to simplify this further, bring the 4 up, comes x to the 4th. And e natural log of x to the 4th is x to the 4th. E natural log of anything is the thing itself. I found I of x. Then we multiply the given equation, the 4x cubed y plus x to the 4th y prime equals sine cube x, both sides by I of x. So which is x to the 4th, x to the 4th. In a way, we are expecting the left-hand side to become I of x times y derivative, and the right hand side stays the same. We integrate both sides. The integral will drop the derivative on the left side, and here we got integral of 1 minute. So when what we get on the right side, we got, if you go back up, this is what we have. This is the equation. So when we multiply by x to the fourth, we do it after we do the division. So here we need to rewrite this as 4 over x and x to the fourth. So this way it will make the right hand side just x to the fourth, sine to the third x. When we integrate both sides, the integral on the left side becomes simply, or the term becomes x to the fourth y, integral of sine cube x dx plus c. How do we integrate sine cube? So to integrate sine cube, we use trig integrals, where we rewrite it as sine square x and save a copy of sine x dx. So because the exponent is odd, so now what we do after we save the copy of sine, we convert the remaining into cosine. Sine x dx plus c. Keep this the same, and how we're going to integrate this one? We can use the u sub. U equals cosine x, du is negative sine x dx. So you need a negative out. Integral of 1 minus u square du plus c. Keep the left hand side the same. The integral of 1 is u plus u to the third over 3 plus the c. Then we replace the u back with cosine x. With cosine x plus cosine cube x over 3 plus c. And as a final step, you could divide everything by x to the fourth power. So you get negative 1 over x to the fourth cosine x plus cosine to the third x over 3x to the fourth plus c over x to the fourth. So as an application to this, one application we use in physics a lot, those who took physics or taken physics, you're going to come across, is the electric circuit. Electric circuits. What do we have in electric circuits? If you remember how the electric circuit looks like, so we have E here, R, L, and this is the switch. Now, in these electric circuits, sometimes this is applied usually to batteries or generators. You know how this works. And it produces a voltage, okay? So with what we have something called Kirchhoff's law, states that the sum of L di dt plus Ri, these two are called voltage drops. So the sum of the voltage drops is equal to the E of t, which is the supplied voltage. So I'm going to specify each one of them. E of t is supplied voltage and that's in volts. We have the I is the current in amps. That's the unit measure. We have R is the resistance in ohms, which we use this sign, ohms. And we have L, inductance, in H for henries. So if we look at that equation up there, this equation is actually a first order linear differential equation. And in physics, they are interested to learn how to solve such equation, right? How to solve such equation for I. Because instead of y, we have I here. So di dt, that's like I prime, right? Suppose in a simple electric circuit, like the one I showed above, the resistance is 12 ohms and the inductance is 4 henries. If the battery gives a constant voltage of 60 V and the switch is closed when t is 0. So the current starts with I of 0 equals 0. Find part A, I of t. B, the current after 1 second. C, the limiting value of the current. They ask us to find I of t. If you go back to the equation, again, as I said, I of t is like y. It's like, so basically they're asking you to solve this differential equation. So the formula, it's L di dt plus, if you scroll back up, this formula here, Ri, or R times I, equals E of t. Let's see what they give us. They first give us the resistance 12. So R is 12. Then they said inductance is 4H, 4 Henry, so that's L. And they give us the voltage 60, so that's E of t, E of t. And then we'll come back to a condition they put on that. It says I of 0 is 0. I of 0 is 0, right? Let's substitute the numbers in. So this becomes 4 di dt. R is 12I. E of t is 60. So then you could divide everything by 4. So di dt plus 3I equals 15. Now it looks like the first order linear differential equation that we started the lesson today with y prime plus p of xy equals q of x. So from here we can say p of t instead of p of x, p of t is 3 and q of t is 15. We find the integrating factor by using the formula e to the integral of p of t, which is 3 dt. That's e 3 ln of t. That gives us e ln of t to the third, which is t cubed. Wait, why there's ln? That's t only. 3t. It's actually much easier this way. We thought there's a fraction. So e to the 3t only. So what are we going to do with this? We are going to multiply that equation that we just obtained, the di dt plus 3I equals 15 e to the 3t. And as we agreed earlier, this is going to turn to be a derivative of the integrating factor that we got, the integrating factor times y. But remember, y here is I. And keep this the same. When we integrate both sides, we're going to get e to the 3t times I equals the integral of this dt plus c. Don't forget the dt or the plus c. On the left side, keep it as is for now. On the right side, pull the 15 out. E to the 3t, to integrate that, you do 1 over the 3, e to the 3t, and the plus c down, which simplifies to keep this the same times I equals 5 e to the 3t plus c. Then divide both sides by e to the 3t because I want the I. So you get only 5 plus c e to the negative 3t. That's the I that they ask us to find. They provided us with what we call it initial condition, that I of 0 is 0. So I means I of t, that's what I. So they're saying when you plug in t0, you set the answer to 0. So that gives me 5 plus c e to the 0 equals 0. So 5 plus c is 0. That will enable me to solve for c. And then we can substitute it back in. Then I, or I of t, equals 5 minus 5e negative 3t. So this is the particular solution, we call it. Particular solution. For part B, they said find the current after 1 second. So what we just found, that's the current. We need to find I at 1. All you have to do is substitute t with 1. That would be 5 minus 5e to the negative 3. And if we put that on the calculator, that would give us about 4.75 amps. That was a quick and easy part. Don't ask me this. Part C, we are gonna asking us for the limit of the I of t. I of t, that means when t approaches infinity, right? As t approaches infinity, that's the limiting. They're saying, what's the limiting for the current? It means as t grows really large, what we get. So this would be what we found in part A, which is the 5 minus 5e negative 3t. We're going to find the limit of this. When we pass the limit to this, the 5 stays the same, and the second one, this one here, e negative infinity is 0. E negative infinity is 0. Because the exponential functions goes like this. If you go toward negative infinity, the graph goes to 0. So then the answer would be 5